Welcome to 7.5's Math Moment. Today students learned about tape diagrams and how to solve problems and ratio problems with tape diagrams. So we've learned a couple of different strategies already in this unit. We've learned how to use factor puzzles to help us figure out ratios, and also we have learned to cross multiply. So now this is just another strategy, and it's more of a visual strategy for students to be able to use when working and describing ratios. So we're going to look at this first one. It says solve the proportion using a tape diagram. It says to make princely purple paint, red and blue paint are mixed in a ratio of 5 to 7. How many liters of red paint should be mixed with 21 liters of blue paint? So the first thing that we're going to do with the tape diagram, again, it's a very visual model. So I look to see what my ratio is, and it's 5 to 7. So the first thing I'm going to do is draw 5 squares. And then I'm also going to draw 7 squares to represent 5 to 7. All right, so I have 5 red because red came first in this. Red was the first word here, and 5 is the first number, so I know I have 5 red, and then blue came second, and 7 came second, so I know I have 7 blue. And it is important to kind of label those and make sure that students keep the numbers with the correct label. So then it says how many liters of red paint should be mixed with 21 liters of blue paint. So I don't know how much red paint I need, but I know that I should get 21 liters of blue paint when I'm done with this new proportion, a new ratio. So how do I figure out how much would be in each section of blue if I want a total of 21? Well, I would just have to take 21 divided by how many sections I have, which in this case is 7. So I'm going to take 21 divided by 7, which I know using mental math is 3. And so we have students write in the number that each square represents to make up this 21. So each square is worth 3 in the blue paint, so each square is also worth 3 in the red paint. Now the red paint only has 5 sections. So if this has 7 sections and it's worth 21, this has 5 sections and is worth 3, 6, 9, 12, 15. So my answer is how many liters of red paint should be mixed with 21 liters of blue paint? If the ratio was originally 5 to 7, but now I want to change it to 21 for blue, my new ratio would be 15 to 21, and that 15 would be red. If you have any other questions about tape diagrams, make sure to see your math teacher. Welcome to 7.5's Math Moment, Part 2. We decided to add in another example of tape diagrams to help you with your students' homework because there are 2 different portions of tape diagram problems. One where they're asking, like we showed in the earlier video of 7.5, how many liters of red paint, where they're just asking about one of the pieces of the ratio. And then there's going to be another example where they're asking about the total. So I'm going to show you how to answer a problem like that. In example 2, it says how many liters of red and blue paint should be mixed to make 70 liters of princely purple paint. So again, up here was our kind of setting up the problem. It says to make princely purple paint, I have to do, the basic ratio is to mix 5 parts red to 7 parts blue. So this question is asking me how much red and blue would I need to make 70 of the purple? So I still have to draw out my tape diagram just like I did with the first problem. And I have to show 5 and then 7. But in the first problem, I knew how much I wanted for the 7, and I was just finding out the 5, or the red. So in this problem, I want both of them put together to equal 70. So in order to find out what each square is worth, this is just like a division problem. I have got 5 plus 7 squares, so I need to find out what each one of them is worth, I have to do some division, 70 divided by 12. So I'm going to go ahead and solve this problem. 12 cannot go into 7, but 12 times what gets me close to 70? I'm going to try 6. 6 times 2 is 12. 6 times 1 is 6, plus 1 is 7. That's a little bit too much, so I need to take it down. 12 times 5, 2 times 5 is 10, 5 times 1 is 5, plus 1 is 6, so that gets me 60. When I subtract, I'm left with 10, and I bring down a 0. So I'm going to say, how many times can 12 go into 100? I already know that 12 times 6 is really close, but I need to go higher than that. So I'm going to try 12 times 9. 9 times 2 is 18. 9 times 1 is 9, plus 1 is 10. That's a little too much. So I'm going to go down to 9 times 8. 8 times 2 is 16. 8 times 1 is 8, plus 1 is 9. So I've got 96. When I subtract, I'm left with 4, and I'm going to bring down another 0. I need to place my 8 up here. 12 goes into 40 how many times? I know that 12 times 3 might get me close. 3 times 2 is 6. 3 times 1 is 3. That gets me pretty close, but when I subtract, I'm left with 4 again. I could keep going, but it's going to end up being a repeating decimal, so I can go ahead and stop with 5.83. What that means is every single square that I have is worth 5 83/100, or 5.83. So we would encourage students to go ahead and continue filling out all of these squares just to visualize and understand that doing that division problem allowed us to realize and find out that each of these squares are the same. It just happens that to make the purple paint, I have 2 extra of the blue than I do of the red. So then to find out exactly how much red I have and exactly how much blue I have, I need to take my 5.83 times 5, which is how many squares I have for red, and then I would need to take my 5.83 times 7 to find out my answer for blue. So I'm going to go ahead and solve those problems. 5 times 3 is 15. 5 times 8 is 40, plus 1 is 41. 5 times 5 is 25, plus 4 is 29. 2 numbers are behind my decimal in my problem, so I want 2 numbers behind my decimal in my answer. So I know that I need 29.15, or 29 1/1500 parts red paint. And now I'll figure out how many parts blue. 7 times 3 is 21. 7 times 8 is 56, plus 2 is 58. 7 times 5 is 35, plus 5 is 40. 2 numbers behind my decimal in my problem mean I need 2 numbers behind my decimal in my answer. So now I know that blue, I need 40.81, or 40 81/100 parts. Sometimes when students are working with proportion problems like these and they use tape diagrams, they're going to get even numbers in the boxes, just whole numbers, and it's going to make it go a little bit faster. Sometimes they'll get decimals, and sometimes they might even use fractions. So they're learning all different ways to use these tape diagram problems in 6th grade. But if you have any questions about using tape diagrams, make sure to see your math teacher.